Welcome back. During this lecture, we are going to talk about more into parameter passing and then different methods of passing data into functions. So, the technique that we are going to discuss during this lecture is called pass by reference technique. In the previous lecture, we talked about pass by value, where the value of the parameter, the data will be copied into the parameter, and then the function is taking the copy of the data value. But in here, we are going to talk about how we can pass the location of the original data value, so that function can go ahead and access the original data location rather than accessing the copy. All right. So this technique is called pass by reference. So one of the easiest way for us to kind of visualize this is that, so think about having a paper. So and then let's say you are having this paper with you, and then you want to give a copy of the paper to your friend right here. So then what you do is you make a copy using the copy machine and then give the copy to your friend. So then you still hold the original and then your friend is having the copy of it. But if you use pass by reference technique, so this is pass by value. If you have the pass by reference technique, so what you do is actually, rather than giving the copy, so you're pretty much handing over the original to your friend, and then your friend is going to take the original. So you no longer have the original only shared by you, but the original is pretty much shared by both you and your friend. So then what are the changes that your friend makes will happen in the original document itself. So therefore there are no two copies, so it's only one copy, right? So then this technique is called pass by reference. So let's take a look at it in the programming context and then see how we can do this in C++, and then what are the benefits of doing so. Okay. Now first of all, then so when you want to pass the reference of a particular variable into the method, so that essentially means we are passing the memory address of the original data item to the function. So as soon as we give the memory address, so then function can use that memory address to go to the memory location where the original data is stored and then use it. Okay. Now in order for us to designate that a particular parameter is a reference parameter, so we need to use this special symbol called ampersand. So now if you have the ampersand value in a function parameter, that essentially means that parameter will be passed as references, right? Now in here, for example, in this method, so it is taking an integer parameter as a reference parameter. So therefore what are the value that we are passing into this particular method will be passing the memory address of that particular memory location. All right. So here is one quick example. So suppose I have a method called triple. That method is taking an integer value as a reference parameter and then tripling it, right? So then implementation of that one is we take the number as a parameter, as a reference parameter, and then we are changing the number by multiplying it 3 times. So it's triple pretty much the value. That means that num to the power 3, right? So now if I want to kind of run this program and then see what happens here, so this is essentially the operation that is happening in this particular program when I'm passing data as a reference, right? Now when we allocate memory, we know that we allocate memory for the main function and the triple method separately in the computer memory. So then inside the main method there's a variable called number. So its initial value is 2 when you assign 2 to that particular variable, and then so we are calling the triple function by passing the number as the parameter. Since the parameter that triple function is taking is a reference parameter, so what you are doing is actually we are passing the memory address of number, not the value stored in the number, right? So therefore inside the function, so we are taking that reference into the num parameter. So therefore num is going to have the memory address of the number, right? So whenever we say that a particular data member is holding a memory address of another, that essentially make it point to the same memory location where the original data is stored. So therefore num is also pointing at the same memory area or the memory location where number is stored. Okay. Now whatever the changes I do using the num will happen in the number itself, right? Then here we are adding multiplying the number 3 times. So therefore 2 times 2 times 2, so that's going to be 8, and then we are saying num equals 8. So when you say num equals 8 in this particular operation, so we are pretty much going to the number when we refer to num. So another way to think about this one is both number and the num are aliases for the same particular memory location, right? So therefore whatever happens to number will happen to num as well. So then in the function we are saying num equals num times num times num. So therefore we are pretty much since this one is pointing at the number variable, so then we are going to put the calculation back in the number variable. So therefore the original data is changed, right? So then if you have pass by reference technique, we can change the original data value in the caller. Okay. Right, so here is another example. So let's work out this one and then see how variable changes as we execute this particular program. Now in here again we have 2 methods, so main method and the fun1 method. So when we allocate memory for it, then so we allocate memory for the main method, so as well as function 1. So then this is for the main method, and this one is for fun1, right? Now in this particular function we have 3 parameters. So first one is an integer parameter. So that integer parameter is passed as a copy value because there is no reference in here. Okay. So therefore first parameter is passed by value. The second parameter is passed by reference because it has a memory address. Now third parameter is passed by value. Okay. So then inside the main method, so we are declaring 3 variables. So first one is num1, second one is num2, third one is a character variable. Okay. Now after declaring these variables, we put values into num1, num2, and then ch, right? And then we are calling fun1, num1, num2, num3, right? So then when we say fun1, num1, num2, and then actually ch. So when you do that, so we are going to the function. So inside the function we have 3 variables. So first one is variable a. Now variable a is correspond to num1. So since first parameter is passed by value, so we are making a copy of the value stored in num1. So that's 10, and then that copy will be stored in here. Okay. Now num2 is a reference parameter. So therefore b on the other hand is getting the memory address of num2. Since b is getting the memory address of num2, so b will essentially point at num2. Okay. So therefore it's not going to hold the value stored in num2 but it's going to hold the memory address of num2. Okay. And now the third parameter is ch. Now ch is again passed by value technique. So therefore v in here as a character variable. So inside the function is getting the value stored in ch. So that's going to be a. So then a will be stored in here. So that's how the memory map looks like. So after this method call. Now inside the method, so we are declaring another variable called 1. So int 1. So then we have integer variable called 1. and then we are saying 1 equals to a. So then things stored in a will be copied to 1, and then we say a plus plus. That means that we are going to increment a by 1. So then a will be 11 at this point. Okay, and now we are saying b equals b times 2. Now when you say b equals b times 2, b is pointing at num2. So therefore we will be changing num2 to 30. So then 30 is the new value for num2. Now we are saying v equals b. So therefore v will be changed to character b. So that's a snapshot of the computer memory after executing the method, right? So therefore after executing the method, so values stored in the original variables, num1 is going to be 10, num2 is going to be 30. So that will be changed after the method executed, and then character is going to be a. We are not going to change it inside the main, but character stored in the function has changed to b, but it really doesn't have any impact on the main method because it's a pass by value technique, right? So therefore when you're writing a method, so we can write a method in a way that we have pass by value as well as pass by reference techniques in combination. All right, now why do we do something like this? So usually we have pass by value and pass by reference in combination, especially when you when the function wants to return more than one value to the caller. So if the function wants to return more than one value, we know that we cannot use the return statement, because return statement can return only one value. Now if you have to return more than one value, so then we can pass the memory address of the value that needs to be returned, and then we can use that one to update the original data, right? So here is one quick example. So suppose we need to write a function to calculate the area and the perimeter of squares as well as rectangles. So and then return area and the perimeter to the main. So since we need to return area and the perimeter to the main, so in both of these cases we will be returning more than one value. So since we cannot return more than one value to the caller, what we can do is actually we can take area and the perimeter variables declared in the main memory area for the main method as reference parameters, right? So then here is let's say the square function. So we can write it as a void because we will be passing data as a reference this time. So SQUARE square, and then we are passing the size of the square. So that's the side length. Okay, and then we will be passing an integer reference to area and integer reference to perimeter, right? Now inside this we are essentially going to change the area to area equals side times side, and perimeter equals side plus side multiplied by 2. Okay, so that will give us the perimeter. Okay, now when we are calling this, let's say in the main method, so we can have an integer variable called side, and then let's say side equals 10, and then you can have two integer variables for area and the perimeter, and then you can call square side area and perimeter, right? So then after executing the function, so first thing is that then we'll be taking this value and then passing this one as a copy. So then side will be 10, okay, and then these ones area and the perimeter, so we are passing the memory locations. So therefore this one will essentially be pointing at this variable, and then this one will essentially be pointing at this variable. So therefore whatever the changes that we do to the area and the perimeter inside the square method will happen in the main, right? So then passing more than one value from a function, so we can use the pass by reference technique, right? So here is another usage of pass by reference. Usually when you're passing arrays into a method, so arrays are always passed as references, right? Because array is a collection of data. So usually when you're passing a collection, rather than copying it, so we pass only the reference to it. So that will actually save a lot of computation time, right? However, when we are passing arrays, we don't need to explicitly say that array will be passed as a reference. By default, arrays are passed as references, right? So suppose we have a method called initialize array, and then we'll be taking integer array as a parameter, and then the size as another parameter. So when you're calling this method, so we can pass this myArray into initialize method with its size. Now inside the method, so we are taking this myArray as a reference parameter to A. So therefore in the main memory area, so then function is having this A variable as a reference to the original array. That means that it will be pointing at the first location of the array to begin with, right? And then size will be passed as a value, so then copy will be passed into the method, right? Now inside this for loop, so what happens is that we are initializing ai to be 0 for each I value. So then I start from 0, and then A is referring to my array. So then A0 essentially means my array 0. Okay, so then we put all zeros in here, so that essentially initialize the original array inside the main method, right? So therefore arrays are always passed as references in C++. Okay, now let's do a couple of activities related to this and see how we can actually kind of understand this a little bit better. So suppose when you write a function called print array that displays the content of an array, right? So so then method is going to be a void method. So let's say print array. For this method, then we need to have two parameters. So first one is an integer array A as a parameter, and then we need to know the size of the array. That means how many elements are stored in the array. And then we can run a for loop in here. You can say for int I equals to 0, I less than the size of the array, and then I plus plus, so cout ai. So that will display the content of the parameter a into the monitor, right? So then if I have then original array, let's say in the main memory like this, with the data values in here 15, let's say 20, something like that. Okay, and then if I call this array x, so then if I call the method print array x and then let's say size 10, so then x will be copying its memory address to A. So then A will essentially be pointing at this first value right here. So then we run through the loop in here, so we'll be taking each of these values and then displaying them. Okay, so here is another example. So write a function sum array that add all the elements in the array and then display them. So that's very similar to the previous one. So then here again, so we take the array and the array size as a parameter. So we call it sum array, and then it's going to be an integer array A as a parameter, and then we need to have integer parameter that specifies the size of it. Okay. Then for int I equals to 0, I less than size, I plus plus, and now we need to have a sum variable initialized to 0, and then you can say sum equals sum plus ai. So that essentially is running through the array and then adding all the elements into the sum, and then finally so we'll have the sum the total values stored in the array. Okay, now one thing however, though functions cannot return arrays as return types. So therefore a return type of a function cannot be an array. For example, this type of a definition is incorrect. right? So if we want to return the array as a parameter, so we essentially needs to have it as another parameter into the function, and then we can modify the array inside the function if you want to do it that way. Okay, so that's kind of the only way to do that. Okay, so let's do a checkpointing question and then see if we understood this concept, pretty well. Okay. All right. So then, in summary, when you are passing parameters into functions, we discuss two different techniques of doing that. So, pass by value technique and pass by reference technique. We can use these two techniques in combination in writing functions. So, the difference is when you have pass by value, the copy of the original data is made and the function works on the copy. So, therefore, what are the changes that happens to the local copy inside the function does not reflect on the original data. On the other hand, so references are memory addresses. So, therefore, pass by reference means we are passing the original data location to the function. So, then whatever the changes that we do inside the function happens in the original data, right? So, that's kind of the main difference between these two techniques, right?